All right, so I'm going to do a little demonstration of what I think is the capabilities of this Pix4Dmapper. If you're like me, you've seen demonstrations of the magic of Pix4D online and have wanted to link your drone, if you have one, to the capabilities that Pix4Dmapper provides. And I started off by downloading what I thought was a trial version of the software to my program, to my computer, only to discover that the most critical feature of Pix4D for the Pix4D mapping capability is a feature called orthomosaic, and that's disabled when you have the kind of pre-trial version of Pix4Dmapper, it turns out. Pix4Dmapper has what they call a discovery mode, and I was trying to create images using that, and only after a communication with their technical team did they offer me a 15-day trial license, a true trial license. And so we're going to see how that works. I'm going to start off by just calling this an aerial, and I'm going to create a new project for myself in my professional development folder, and I'm going to add images. This is my these are the images from my quick flight over my office. I'm going to include everything except the kind of the incidental images that were here at the end as I was landing the drone. So there are 21 of these aerial images all looking down. They say that enough images are selected. Press next to proceed. Things are looking good. Okay, so I'm going to go next. And it's got this datum, WGS 1984, which is a very typical datum for aerial photography. It has successfully geolocated all 21 images. And just a brief aside about that. This is kind of what I struggled with initially. I would fly my drone over territory and think that things were going pretty well, but it turns out that there's a thing called EXIF information that can accompany a digital image, and that EXIF information gives more information about the picture than just the image. It also gives the geolocation of the picture, and it might even give the orientation of the picture as well. When one flies drones, it's really easy to. I'm going to start this cooking as I'm talking. It's really easy to think that you're recording geographic information. The drone will say GPS recording, but it turns out that to truly be in GPS mode, both your GPS signal needs to be working properly, you need to be in touch with all the satellites, and your compass needs to be working, which means that you can't be too near metal objects. And that is, I think, one of the most common modes of failure with drone photography. I'm going to forward this while I'm talking. So I'm just going to say next here. Just to finish that thought on the drone photography, so one thing that will often happen is that when you're taking off with the drone, you're near a metal object. So once the drone gets up in the air, it should be fine, but you want to definitely make sure that both the compass and the GPS signal are working well when you take off, so that your drone can reliably record its positional data as it's running its flight. All right, so we're going to do this standard 3 maps mode. This is the mode that I tried before and was not able to get this coveted orthomosaic generated, and this is the thing that is not available even with the pre-trial version. You make the mistake of downloading the software and thinking that you're going to be able to see it do some mapping, but it will not do that until you get a trial version, which I got just by writing them a complaining email, and then they sent me a 15-day trial, and I think they'll do that for anyone. So I'm going to say finish, and then the magic starts to happen, and it shows you, really the exact flight path that you took over, wherever it was you were. And this is essentially stealing the EXIF information off of the individual images and positioning them crudely, where they are in space. And GPS signals aren't super precise, so it still has to do some interpolation and estimating, but the EXIF information apparently, just narrows the field of possible orientations of these images sufficiently that the computer can work with these images. You can see that down here in the lower left-hand corner, there are three processes. There's an initial processing, a point cloud and mesh processing, and a DSM, orthomosaic, and index. And it is this DSM, this number 3, orthomosaic and index, that was not checked when I did this before, to my great frustration. And so I only had a 1 and a 2 in this lower bar, not a 3. So we're going to see what it does with it this time. Does this quality check? There's one thing that I think one could do as an extra precise measure, and that's this georeferencing. There is no geographic or geologic control point that I've pointed out, but apparently, you can identify some fixed point in one of your images that definitely has a very precise control point, and I guess that would help the images even further, but I don't think that that's going to be an issue. You can see an indication of where we're headed with this, which looks very promising. I'm going to say close, and even here you can see that the point clouds have already been generated, or, well, excuse me, that's not accurate. We're still in phase number 1, which is the initial processing. But even then, you can see that it's starting to see the landscape. You can see the roofs of the structures. And I don't know why there are these two bichromatic kind of indications of the images, why there's this blue that's skewed to the image. I'm not sure what the purpose of that is. But in any case, these are essentially where the images were taken in space relative to our foggy understanding of the land that's underneath it. We are finishing up that first process and going into point cloud now. So it's doing point cloud, and it's generated, what looks like now, yeah, almost 3 million images, or 3 million points. So this is kind of the magic of point clouds, is all of this point calculation. But yeah, I have to say, like, I've struggled to generate these images in the past, and it really, the big breakthrough was this GPS mode on the drone. I guess drones have two other modes, Opti and ADI mode. Both of those modes are non-starters for being able to generate these kinds of aerial photography images. You definitely need to be in GPS mode, and contrary to what the name implies, GPS signal is not sufficient. You need to be in GPS mode in the sense that the GPS signal is working, or signals, I should say. You need to be in contact with numerous satellites, and you also need to have the orientation, so the compass of your drone working, and that's as simple as just relocating your drone from being near a metal object to being away from a metal object. So you just kind of do a little bit of a walkabout and wait for the magnetic interference signal that you're getting on your drone controller. You want that to go away. So once that goes away, you can take off and get up in the air. And once you're up in the air, you don't have to really worry about that anymore. But it's that threading of the needle of finding a place to exit the Earth that I think is mission critical for making this magic that we're seeing here happen. Okay, so we have a point cloud densification. Looks like we are done with the point cloud calculation. And so number of densified points, looks like there's 3 million. And there's one tile, which is good. That means there's one cohesive image. And yeah, there's going to be several of these. Forgive me, I wish I could make the computer screen noise softer than it is. Maybe I can actually dial down the volume of that. I'll try that. But there's going to be numerous temporary files that are created and then deleted. So I'm going to get this image. I'm going to say, don't ask me again, so you guys aren't bothered with this. But anyhow, so I guess we're doing this, getting close to it being done. I'm going to close this out. Yeah, we're through this process number 3, about halfway through this process number 3, which is, as I mentioned before, the process we're most interested in. I wish I knew what DSM stands for. digital something, I don't know, but it is this orthomosaic that we're most interested in. And I think when it does the orthomosaic, it's going to automatically export it. So I started to try this earlier and hunted around for an export, a way to export it, and it turned out actually that it had done it by default. When it does the orthomosaic, it automatically exports an orthomosaic to the project folder, and I can show you that afterwards, and that can be opened up. It's a TIFF file that can be opened up in Photoshop or any other you know, photo viewing software. And yeah, one of the other things that I suspect will be a potential issue is where the camera is able to see from different vantage points quite different images of the terrain, and which happen, I think, most often at like building corners where there's an eave. And you know, if the camera is directly over the corner of the building, it sees the corner. But if there's a little parallax and the camera's off to the side, it might see a bush that's underneath the eave. And so I think you will be seeing a little bit of ambiguity at the corners of the buildings, but you know, we'll see. Anyhow, okay, so I'm going to close this out. Everything looks like it generated. It took about 1.5 minutes to generate the orthomosaic. I'm going to close this. We're still in Ray Cloud mode here. I'm going to go to the mosaic editor, and here we should see the magic. As soon as it processes this, you can see it's kind of analyzing it down there in the lower left-hand corner. And here we have it. Look at that. So kind of zoom in here, and I mean, not bad. So go around here. Everything looks good. Yeah, look at this. Okay, I mean, that's pretty great. High resolution. You wouldn't get this on Google Earth. Okay, this is kind of what I'm seeing. You see this kind of rounding of the corners here. So that's a little bit of an aberration. You've got a bush here that's kind of poking out from underneath the eave of the building, but otherwise pretty darn good. Everything looks like it's really taken pretty much overhead, which is, you know, great. So I'm going to go down here. I'm going to see if I can find this thing in the Pix4D research. I'm going to open up Aerial. Let's see, this is the file that was generated today. Go into the ortho, DSM ortho mode. Go into mosaic. And here we go. I'm going to open this up. Let's try opening it up in, well, I guess I'll just preview it. And that's on my other screen. So there you have it. There it is, just previewing on the typical Windows screen. So I hope this has been helpful. Yeah, I mean, a pretty effective device now that I've got the kind of, I think the biggest hurdle to generating something like this is understanding the initial settings of your drone before you take off. And then I just hit the, you know, I just kind of sporadically hit the picture taking mode. I think maybe the next more advanced way of doing this is to generate an auto flight and get very strategic about where you take your waypoints, so you can actually run routines where you do a very methodical zigzag pattern and take pictures at regular intervals. But you know, you can see from this that that's not necessarily critical. You just need to make sure that there's plenty of overlap in the images that you have, you know, like we see here. And so you can see this was not at all regular, and yet it still generated a pretty effective image. All right, I hope that helps.